Determining quadratic functions. Today we're going to get involved with the process of solving or writing equations given the roots of functions. In the first example, what you are given is a graph. In order to determine the roots, you find the place where the graph touches the x-axis. That means it's going to be x equals -5 and x equals -2. This is the process of working backwards through the algebra. So the previous step in solving this problem for these two solutions was to get x by itself. So moving backwards through the algebra, we're simply going to move the solutions back to the other side of the equation alongside of x, and that will give us the binomials that are the factor pairs for the given graph in standard form. So we're going to add 5 to both sides and add 2 to both sides. Your first binomial for this quadratic is x plus 5. Your second is x plus 2. In order to write it in standard form, we simply have to distribute it or FOIL it out, and that gives us x squared plus 5x plus 2x plus 10. Simplifying like terms, x squared plus 7x plus 10 is the equation of this quadratic in standard form. Writing a quadratic function in standard form, ax squared plus bx plus c, with the given zeros, remember 0 is a solution, a root, is the same process. We will say, first of all, that x equals -3/4. Next, we'll say that x equals 2. In this case, rather than just adding the fraction back over to the other side, what I'm going to do instead is I'm going to take it apart piece by piece and then move each number as a single number rather than a whole fraction. So I'm going to multiply the 4 first by moving it to the other side of the equation. 4x equals -3. So I'm going to add the 3 to the other side. And my first binomial for this particular quadratic is 4x plus 3. Subtract 2 to both sides, and x minus 2 is the second binomial. Multiply them together to get it in the standard form, 4x plus 3, x minus 2, and I get 4x squared plus 3x minus 8x minus 6. The final solution, or the final form of the equation in standard form, is 4x squared minus 5x minus 6. Question number 3. Writing a quadratic function in standard form that has an x-intercept at -6. Now, although this can be interpreted that there's another one somewhere else, we're going to make the assumption that this particular quadratic crosses the x-axis only once, and the place where it crosses it is at the number -6. Okay? So that means what I have here is 2 answers, x equals -6 and x equals -6. That's typically what happens when there's one single solution. What you're going to end up with is a perfect square trinomial. Adding 6 to both sides of the equation, I get x plus 6. Remember that with a perfect square trinomial, you've got both solutions. So it's going to be the positive and negative answer, which is why we square it, and it becomes x squared plus 12x plus 36. Additionally, we can solve using roots that are imaginary as opposed to real. Now the process here is a little bit more involved, but it is exactly the same as what we've been doing before. We're going to set it up as x equals -2 plus or minus 3i. Then what we're going to do is we're going to move the 2 back to the other side using addition. We get x plus 2 equals plus or minus 3i. It's at this point that we write our two equations. Our first equation is going to be x plus 2 equals positive 3i, and x plus 2 equals negative 3i. The next step, subtracting 3i to both sides. X plus 2 minus 3i equals 0 is our first, trinomial this time, but it's actually a binomial with a real and an imaginary part. And then it's x plus 2 plus 3i. So now what we have here is a more complicated factoring or foiling problem or distributing problem, but it's not anything more than we've dealt with in the past. So it's x plus 2 minus 3i times x plus 2 plus 3i. You're going to get x squared plus 2x plus 3i times x plus 2x plus 4 plus 6i minus 3x times I minus 6i minus 9i squared. Multiply each factor each time. Now what happens is you get a whole bunch of terms that cancel each other out. This term cancels with that term, and this term cancels with that term. What's left is your solution. X squared plus 2 and 2 is 4, 4x plus 4, and then we've got this little guy right here. Remember, I squared is equal to negative 1, so negative 9 times negative 1 gives us 9, and that's going to give us 9 plus 4, which is 13. The next one, a little bit more complicated, but still the same process. Don't get intimidated just because you see that fraction. It is still the same. X equals 1 plus or minus I times the square root of 5 divided by 2. This process will begin by multiplying both sides by 2. Now I get 2x equals 1 plus or minus I times the square root of 5. Subtract 1 to both sides, and I get 2x minus 1 equals I root 5, and 2x minus 1 equals negative I root 5. It's at this point in time that I multiply these two together, after moving these back over, and I get 2x minus 1 minus I root 5 times 2x minus 1 plus I root 5. Now we multiply them out, and we get 4x squared minus 2x plus 2I square root of 5 plus 1 minus I root 5 minus 2I root 5 plus I root 5 minus 5I squared. So this cancels with this cancels with that, and what's left is what my solution is going to be. Oops, I left out a 2x, sorry. There should be another 2x right in here, negative 2x. Those of you following along should have caught that. So we've got 4x squared minus 4x, and then plus 1, and then this guy right here becomes negative 5 times negative 1, and that's going to be 5, so 5 plus 1 is 6, and I get 4x squared minus 4x plus 6. The last three questions look at the problem from a slightly different point of view, and what we're going to do to solve it is using a version of the calculator that's going to help us, or a process inside the calculator that you guys are familiar with, and it's going to help us find our answer. Okay, so we know that we're looking for an answer in standard form. We know that that answer has got to look like this: y equals ax squared plus bx plus c. So what we have here are three different places where we can plug in a number for the x and y. And if we have three variables, we can create a three-variable system with three separate equations. And if we can solve a three-variable system, we can use the matrix to help us get the answer that we need. Remember, solutions are where it touches the x-axis, therefore the ordered pair at 3 and at 8 is going to be 3, 0, 8, 0, and then of course our third point is 2, 3. Using those three ordered pairs, using this form of the quadratic, we're going to set up three separate equations. The first equation is going to be 0 equals a times 3 squared plus b times 3 plus c. The second equation is going to be 0 equals a times 8 squared plus b times 8 plus c. Our third equation is going to be 3 equals a times 2 squared plus b times 2 plus c. We're going to use the matrix to help us out. This will be our second matrix. Sorry, I wrote it backwards. And this will be our first matrix. Your coefficients go in to the matrix, and the solution we get is f of x equals 1/2 x squared minus 11 over 2 x plus 12. Number 7 is just like number 6, so go ahead and pause the video now and see if you can come up with a solution before you move on. So the three equations you should have come up with were 0 equals negative 2 over 5 squared a plus negative 2 over 5 b plus c. Should be 30 negative 1 squared a plus negative 1 b plus c. Negative 24 0 a plus 0 b plus c. Your solution to this matrix was f of x equals negative 10 as your a, negative 64 as your b, and negative 24 as your c. The second way we're going to solve these problems is by using regression. Okay? Now we've already learned about linear regression. Now what we're going to look at and focus on is quadratic regression. And the thing to remember about quadratic regression is that you need at least 3 points. This is 3 points, so we'll be okay. Linear regression requires only 2 points. Quadratic regression requires 3. So you want to go to your calculator, stat function, go to edit, and enter in your ordered pairs. Once you've entered in your ordered pairs, you are going to hit your stat key once again, go to the right and go find your calculate screen. Linear regression was number 4. Now we are going to introduce quadratic regression. Quadratic regression is number 5. So number 5, you're going to make sure that you've got the proper lists and hit enter all the way through and have it calculate. Once you have it calculate, you'll see your quadratic function in standard form, y equals ax squared plus bx plus c, where a is 3, b is -5, and c is 1.